This is project 4, question 3 on electron configuration. So this problem wants us to find the electron configuration and the abbreviated electron configuration of a neutral atom of copper, and to answer the question of if copper follows Hund's rule and why it does or why it doesn't. So to start, we need to know how many electrons are in copper, which is 29. And copper is one of the weird elements. It doesn't follow the normal Aufbau's principle. So what we would expect to see if we followed it perfectly, just following along with the periodic table until we hit 29 electrons. So we would have 29 electrons here. But the state of an atom is more neutral when the shells are half or completely full. So it doesn't follow Hund's rule, and Hund's rule is basically stating that a lower energy shell is completely filled before moving on to the next one. So what copper's actual electron configuration is basically the same up until a certain point. Up until this point. So for here, the 4s orbital isn't completely full, it's half full. So it gives 1 electron to the 3d orbital so that it can be full. So since this one is half and this one is fully filled, it can be more stable than in this form. So this is the only part that changes, which would be the full electron configuration. To do the abbreviated, you find the noble gas that is closest. In this case is argon, which has 18 electrons. So if we take 18 from the 29 that we started with, we have 11 more electrons to fill up the shell. And that would just be the 11 electrons here, because this is basically the electron configuration for argon, and this is just what we have left over.